Hey guys, today we're going to be looking at chapter 7, problem number 7. The question states, a force F is equal to 6I minus 2J acts on a particle that undergoes a displacement of delta R, which is equal to 3I plus J meters. Find A, the work done by the force on the particle, and B, the angle between F and R. The first thing we need to do is identify the given. It gives us a force, which is equal to 6I minus 2J newtons, and it also gives us a distance, or delta R, which is equal to 3I plus J meters. Next we identify the find. In part A, they want us to identify the work done by the force on the particle. Work is also represented by the force times a distance. And in part B, they want us to find the angle between F and R. In order to solve this, we will need the work formula. Work is equal to a force times a distance. In this case, that force is the force in the x direction times the distance in the x direction added to the force in the y direction times the distance in the y direction. And we have these values. The force in the x direction is 6I, or just 6 newtons. That's going to be multiplied with 3 meters, or the distance in the y direction. Using the formula, we'll add that to the force in the y direction, negative 2 newtons, multiplied by the distance in the y direction, 1 meter. 6 times 3 is 18, plus negative 2 times 1, which is negative 2. With some simple algebra, 16 Newton meters becomes our force. This is the answer for part A. So now let's take a look at part B. They want us to find the angle between the force and the distance. The equation is theta is equal to the inverse cosine of the work, which we found in part A, over the sum of the forces multiplied by the sum of the distances. In this case, that's equal to 16 Newton meters, which is the work, and that's divided by 6 newtons plus negative 2 newtons multiplied by 3 meters plus 1 meter. Now, because there is a negative in the denominator, what they have you do is square each individual value and then square root it at the very end. Now, using basic algebra, we find that yields 16 divided by the square root of 40 newtons times 10 meters. Using some simple algebra, oh, and don't forget, this is the inverse of the cosine. Now, using basic algebra, we can find that the degrees is 36.9 degrees. That's the answer for part B.